Good morning friends. Today I am going to explain what is PN junction diode. In this, first of all we will talk about what is diode. First of all, what is diode? Secondly, we are going to talk about PN junction diode. And finally, we are going to talk about the working of PN junction diode. Of PN junction. So first of all, what is diode? So diode is nothing but it's an electronic device which consists of two electrodes, namely cathode and anode. The definition of diode is an electronic device with two electrodes namely cathode and anode, and these diodes are mainly classified into two types. That is, first one is vacuum diodes and second one is junction diodes. So in olden days we were using this vacuum diodes, in which there is a glass bulb was there, and this one is totally evacuated bulb. In between there is a plate, and this is known as the anode, and this one is known as the cathode, and there will be a one filament to excite the electron from the cathode, and those will be reaching the anode. So in olden days we were using this vacuum diodes. Nowadays we are using this junction diodes. So now I am going to talk about what is PN junction diode. PN junction diode. Generally, these PN junction diodes are formed either in germanium or silicon. Germanium or silicon crystals. So in this, one side is totally diffused with the p-type material, and the another side is diffused with the n-type material. Okay, so when p-type material and n-type materials are joined together, then due to which a plane is dividing this PN, and the plane dividing the two zones is known as the junction diode, or this is also known as the semiconductor diode or crystal diode. Semiconductor diode or crystal diode. So what is PN junction diode? When a p-type material and n-type materials are joined together, generally this takes place in the germanium crystals or the silicon crystals. So this type of formation is known as the PN junction diode. To explain the properties of the PN junction diode, let us consider p side is p-type semiconductor and n-type semiconductors are joined together like this. One more diagram I am drawing this one for better understanding. Here let us suppose this is p-type and this is n-type, and a plane is dividing. So here let us suppose after diffusion process, electrons comes to the p side and holes are to the n side. This is VB, potential barrier. Here, this one, migrated holes. Holes from p side, and these are the migrated electrons. From n side. Okay. So here, and we know that p-type material means there is a high concentration of holes in p side, and n-type material means there is a high concentration of electrons, and there is a tendency of holes to diffuse into the n side, and there is a tendency of electrons to diffuse into the p side. So due to the diffusion of electrons and holes, that is, holes are cross over the p region and enter into the n region, and where they combine with the electrons and becomes neutral. Thus a region is formed which is known as the depletion region, depletion layer, or charge free region, charge free region. Here what will happen, that is, generally we know that p-type material is nothing but a when a trivalent impurities are added into a pure semiconductor during the crystal growth, the resultant crystal is known as the p-type material. Already we understood, we studied about this p-type material, and there is a high concentration of holes in the p side, whereas n-type means when a pentavalent impurity is added into a pure semiconductor during the crystal growth, the resulting crystal is formed, is known as the n-type material, and there is a high concentration of electrons in the n-type material. When these p-type and n-type materials are joined together, so because of this high concentration of holes and high concentration of electron, there is a tendency of holes to diffuse into the n side, and there is a tendency of electron to diffuse into the p side. So because of this diffusion, once these holes cross over the p region and enter into the n region, where they combine with the electrons and form a charge free region, or that is known as the depletion region. And this diffusion of holes and electrons is continuous till a potential barrier is formed, or the junction barrier VB is developed in the depletion layer. So this continuously the electrons from the n side enter into the p side, and holes enter into the n side. Because of this continuous, a potential barrier is developed in the charge free region or the depletion layer, which prevents further neutralization. Thus a potential is developed across the junction. So because of this potential barrier, a potential is developed across the junction, which is known as the junction voltage, or barrier voltage, and this is known as the junction voltage or the barrier voltage of potential barrier. The potential barrier is of the order of 0.1 volts to the 0.3 volts, and once this potential barrier is eliminated from the depletion layer, then the current is flows in the junction. and this potential barrier can be increased or decreased by applying some external voltage. The symbol of this junction diode can be represented as like this here. This is P and this is N, and this is known as the anode and this is cathode. Okay. Now I am going to talk about the working of a PN junction diode. Working of PN junction diode. In order to consider the working of a diode, we have to consider the effect of forward bias and reverse bias. Forward bias and reverse bias across the PN junction diode. So first of all, what is forward bias? Forward bias means when external voltage is applied to the junction in such a way that it cancels the potential barrier and permits the current flow, then the diode is said to be in forward bias. Okay. So what is forward bias? When the external voltage is applied to the junction in such a way that it cancels the potential barrier and permits the current flow. So that is known as the forward bias. And reverse bias means a bias in which the potential barrier is increases, or if we give the connection in such a way that the potential barrier is increases and there is no current is flows through the junction, that is known as the reverse bias. So first of all, I am going to talk about the forward bias. For the forward bias, to apply the forward bias, the positive terminal of the battery is connected to the P side or P type, and the negative terminal of the battery is connected to the N side like this. And due to this, the applied forward potential establishes an electric field which acts against the field due to the potential barrier. As the potential voltage is very small, that is already I told you, that is potential barrier voltage is approximately 0.1 volts to the 0.3 volts, a very small voltage. So for a small forward voltage is sufficient to completely eliminate the barrier voltage. Once the barrier voltage is eliminated by the forward voltage, the junction resistance becomes almost zero. The resistance of the junction is almost equal to the zero, and because of this one a current is flows in the circuit, and this is known as the forward current, and it can be measured in the milliamperes. Next, for the reverse bias, what is reverse bias? When an external voltage is applied to the PN junction in such a direction that the potential barrier is increased. This potential barrier is increased, then it is called the reverse bias. So to apply the reverse bias here, this is P type. P type is connected to the negative terminal of the battery, and N type is connected to the positive terminal of the battery. So the electrons will move to attract to the positive terminal. So automatically this goes to this side, and the holes will be attracted to the negative terminal of the battery. So the applied reverse voltage establishes an electric field which acts in the same direction as the field due to the potential barrier. Therefore, the resultant field at the junction is very strong, and junction barrier is increases. The increased potential barrier prevents the flow of charge carriers across the junction. Thus, a high resistance is established for the entire circuit, and hence the current does not flow through the junction. So this is known as the reverse bias. Of course, there is a small current is flows in the circuit because of the minority charge carriers. That is in microampere. That can be seen in the microampere. And this we will discuss about how this current will be flowing in the reverse bias in the next video. Now we will talk about the conclusion of this working of a PN junction diode. From the above discussion, it is clear that PN junction in the forward bias having a very low resistance. In this forward bias, there is resistance is very low and the current is flows in the circuit. On the other hand, PN junction diode in the reverse bias, it has a high resistance and there is no current flows in the circuit. Thus, PN junction diode is a one-way device which offers a low resistance when forward bias and it offers a high resistance when it is in the reverse bias. And in the reverse bias, it behaves as an insulator. Okay. Thank you. For more videos on different physics topics, please subscribe my channel Physics Tutor.